So in my last class I was explaining to you the gravitation. So far we could complete in the last class that is inverse square law of gravitation and thereafter intensity of a gravitational field. So for that inverse square law of gravitation we have that formula F is equal to capital G m1 m2 by d square, and for the intensity of a gravitational field that is taken capital G m by r square. So that is intensity of gravitational field, and thereafter it is variations of a small g. Variations of small g, under that topic that is variations of small g, we have discussed. So those topics are the altitude and again the depth, next after that latitude. So for that altitude we have the formula. So we have, that is the first one, g h by g is equal to r by r plus h whole square. That is effect of the latitude, sorry, effect of that altitude, that is the gh by g is equal to r by r plus h whole square. So that is the first here, and thereafter when h less than, so if h less than Kepler, in that case gh is equal to small g into 1 minus 2h by r after the application of binomial expansion. But here this is the accurate formula, this is the approximate formula only. So this formula is to be taken only when h is considerably very small, because when h is very small when compared to that value of Kepler, so that is the radius of earth, in that case this formula is not at all useful, because it is highly difficult to find out that value. As I already gave that example also. Suppose if your body is taken to a height of 300 meters of altitude, then what is the percentage change in a small g? In that case 6400 kilometers by 6400.3 whole square, that cannot be taken. 6400 by 6400.3, because we have taken only that 300 meters of altitude. So 6400.3, that is highly difficult to get that division. So that's why in that case this is the best formula. So in that case you will be asked to find out what is the percentage change in a small g. So in that case we are taking a delta g by g into 100 is equal to 2h by r into 100. That is a percentage change in a small g. That is percentage decrease in a small g is that 2h by r into 100. That is the fourth formula is completed. And the next one, when you are going to that deeper into that soil, so deeper into that is a depth effect. In that case the formula is gd is equal to small g into 1 minus d by r is here. Gd, that is in the depth, that is small g of 1 minus d by r is taken, and here this is a accurate formula. And again here in this case when d less than, so if d less than Kepler, that is a delta g by g into 100 is equal to, that becomes, it is a d by r into 100, where d is the depth of that, where d is the depth inside that surface of that earth. Suppose where that body is placed, suppose it is the d is here, now the body is placed here, and in that case then what will be the small g value? So that is a delta g by g into 100, fractional decrease in small g is equal to d by r into 100. So far we could complete, that is the sixth formula also. And thereafter, and one more point is also covered in the last class, was covered, that point is the latitude effect. That is the effect of latitude, and its formula is the g phi is equal to small g. So that is a small g minus r omega square cos square phi. So this is the formula, effect of the latitude. G phi is equal to small g minus r omega square cos square phi. So in this case g minus r omega square cos square phi for all that, and we have taken the two cases also. Suppose at equator phi is equal to 0 degrees, because I already defined that meaning of that latitude also. Latitude is nothing but the angle made by the line joining the particle to the center of the earth with equator, that is known to be the latitude. So that's why at equator phi is equal to 0 degrees, then g is equal to g minus r omega square. So g is equal to g minus r omega square. And at poles phi is equal to 90 degrees, then in that case g p, that is equal to g, small g only. So that's why it will be the maximum value, and here at equator it will be the minimum value. So that's why the variation in between that maximum and the minimum is 5 centimeters per second square, because at poles it will be 983 centimeters per second square, and here it will be 978 centimeters per second square. The difference in between them is 5 centimeters per second square is here. So far we could complete all of them, and for all of them, that is I gave that verification, that is a proof also, and here the inverse square law of gravitational, and it is the intensity of gravitational field, and thereafter it is when the body is taken to height, gh by g is given, and if h less than r, what is the percentage change in small g, and for that this formula is taken, and thereafter when it is taken to the depth, so this formula is also covered, and after that next when it is d is less than Kepler, this is the formula, and thereafter effect of the latitude, this formula is very important, and g phi is equal to small g minus r omega square cos square phi, and we derived it, that formula also that we derived in the last class, and thereafter we have taken the two cases. Suppose phi is equal to 0 degrees, that is at the equator, and phi is equal to 90 degrees, that is at the poles. These are the values. Now suppose if a body is taken, we are taking some simple case on that latitude, effect of that altitude and again that depth. A body is taken from center of earth. A body is taken from center of earth and to that surface, to the altitude like this, from the center of earth. So it is the body is taken from the center of earth. First of all, it is to be taken to the surface, and thereafter it is to be taken to an altitude like this. So that can be taken h like this. In this case, so first of all, this is the r. The body is taken like this r, and it is to be taken to this position. In that case, how that small g changes? How that small g changes? So here small g at the center of the earth is 0. Small g at the center of the earth is 0 because that is small g at the center of the earth means here d will be equal to Kepler, because here the d is measured from surface of earth. So that's why at the center of the earth means d is equal to Kepler, because it is to be measured from the from the surface of earth. So in that case, that is acceleration to gravity at the center of earth becomes 0, and thereafter we are starting from 0. So that's why here you have to take that is 0, and again it passes on like this, because when you are moving up towards this surface, and that small g is directly proportional, is in a linear relation with that distance which is measured from the center of earth, not from the surface of earth, which is measured from the center of earth. So that's why here it is a linear relation, and at the surface it becomes a maximum. And at the surface it becomes a maximum, and thereafter we already know it is a linear, that is g h is equal to gm by r plus h whole square. So that's why it will be taken like this, it is a rectangular hyperbola. So that's why here g proportional to, so that is it is changing like this, and it becomes a maximum. So it will be maximum value, g maximum value, and that a point that we can indicate it is a surface, and here we can give the general distance is a small r. And here this point can be taken as a small r is equal to Kepler, and here that is a small r greater than Kepler, and here in this case that is the center of the earth, small r is equal to 0. So this is the variation of the small g when your body is taken from the center of earth to the altitude above the surface of the earth. So that's why altitude. In that case, we are starting from the center of the earth where small g is equal to 0. So thereafter it is in linear relation, it is in linear relation. So in that linear relation we will have that inclined straight line, and at the surface it becomes a maximum, that is g is equal to gm by r square. So that's why it is a maximum, and thereafter it is g proportional to 1 by r square. So proportional to 1 by r square like this. So that's why it becomes a rectangular hyperbola. So that is in this case we are having so far we could complete, that is the 3 variations, that is effect of altitude, effect of depth, and again the effect of latitude. Now now at equator already we know g is equal to small g minus r omega square cos square 0 at equator, and it is g is equal to small g minus r omega square cos square 0, because already we know at equator phi is equal to 0 degrees, and it becomes g minus r omega square. Definitely it will decrease, definitely it will decrease. G is equal to small g minus r omega square. And now we are coming to some imaginary points. If at all the small g to become 0, if at all the small g to become 0 at equator, then what should be the angular velocity of that earth? if at all the small g to be equal to the 0 at equator, then what should be that angular velocity of Earth? In that case, g is equal to 0. G is equal to 0 means in that case 0 is equal to g minus r omega square, implies omega is equal to square root of g by r. So g minus r omega square is there, omega is equal to square root of g by r is taken. If at all that angular velocity of Earth is this much, then only small g becomes 0 at equator. Small g becomes 0 at equator, that is the first point is covered. And next one, what should be the time period of self-revolution of Earth if small g to become 0 at equator? What should be the time period of self-revolution of Earth? So in that case we are taking, that is a time period of self-revolution of Earth means t is equal to 2 pi by omega. 2 pi by omega already we have got, so that's why it becomes a 2 pi square root of r by g. If you are applying those values, that is a 2 pi is there and r is equal to, that is a 6400 kilometers, and again that should be converted into meters also, that is a 6400 into 10 cube, and g can be taken as 9.8, and roughly it becomes, it is 84.6 minutes. 84.6 minutes. Suppose if at all the self-revolution time period of Earth, the self-revolution time period of Earth is completed within this 84.6 minutes, then automatically small g becomes 0 at equator. That's the meaning is the particles which are on that equator, they experience weightlessness. So that's why if the self-revolution time period of that Earth is decreased to this value, 84.6 minutes, so that is the second point is cleared. Now after that we are coming to this third one. Third one is, what should be that frequency of self-revolution of Earth? What should be that frequency of self-revolution of Earth? So for that we are taking n is equal to omega by 2 pi. N is equal to omega by 2 pi. That means it is the 1 by 2 pi is there and square root of g by r is there. In that case we can have that value if Earth rotates 17 times faster. If Earth rotates 17 times faster to that present speed. So if Earth rotates 17 times faster to that present speed, then automatically small g becomes 0 at equator. Its meaning is the particles at that equator feel weightlessness, experience weightlessness. But in all these conditions, there won't be any change for the small g at poles. It will be as usual, it is the 983 centimeters per second square only. Why? Because here the polar axis means it is nothing but axis of rotation. At the axis of rotation, the particles don't have any linear velocity and linear displacements like that. So because of that, the increase of the speed or it may be the decrease of speed that doesn't affect the particles which are on this polar axis. That's why small g will be as usual 983 centimeters per second square in all these conditions at poles. But here that changes will be that the changes, we can experience those changes when you are moving away from that polar axis. When you are moving away from that polar axis, its meaning is that other than 90 degrees, other than phi is equal to 90 degrees, at any other angle, at any other latitude, you can have that experience, that changes, and that change will be maximum at equator. Why? Because here the equator is the biggest diameter of that Earth. Equator is the biggest diameter. Its meaning is the particles are very far away from that polar axis. They experience naturally more centrifugal force. That's why the change becomes a maximum at equator. So that's why we have considered that at equator small g to become 0, these should be, that is the time period should be like this, frequency should be like this, angular velocity also should be like this. So far we could complete that first phase of the gravitation. So the first phase of that gravitation consists of, so the theory of the first phase of that gravitation that consists of inverse square law of gravitation, intensity of gravitational field, and variations of that small g, and variations of that, under that variations of small g you are having that altitude and depth and thereafter latitude. So like this, now all these are completed. Now we are coming to the second phase, which is more important when compared to that first phase. We are coming to this second phase. In that second phase,